I'm Dr. Courtney with the Quantitative Reasoning Center. Practice is important in music and in mathematics. So let's have a look at 5.4, number 29, and it asks, find the integral from 2 to 5 of f of x dx if f of x is even, in other words it's an even function, and the integral from negative 2 to 2 is equal to 6, and the integral from negative 5 to 5 is equal to 14. And you're like, well, wait a minute. Like, give me a function, a polynomial or something, and I can integrate it. But you know, here we're talking about like even functions, and this integral is equal to this, and the other integral is equal to that. What do we do from here? So when you don't know what else to do, it often makes sense to draw a picture. So we have a function from negative 5 to 5, f of x, and we don't really know what the function is doing, but what it means to be an even function is it means it's symmetric about the y-axis, so whatever it's doing is doing the same thing on either side of the axis. In other words, one of the things that we know is that the integral from negative 5 to 0 of f of x dx has to be equal to the integral from 0 to 5 of f of x dx, because these two regions, these two areas, are mirror images of each other. We also know that the integral from negative 2 to 0 is going to be equal to the integral from 0 to 2 of f of x dx, because these two regions are also going to be perfect mirror images, so because of that symmetry, they're equal. Alright, now let's think what we got. Well, we know this whole integral here is equal to 6, which means each subintegral has to be equal to 3. So this integral is equal to 3, and this integral is equal to 3. Likewise, we're told that the whole integral from negative 5 to 5, the whole thing, so if we shaded the whole region is 14. So what that tells us is that each half is equal to 7. So we've got all these areas running around. The left half is equal to 7, the right half is equal to 7, so they add to 14, and then this region is equal to 3, and that region is equal to 3. So how now do we use this information to figure out what our original integral needs to be? Well, this is the integral from 2 to 5 of the function. So what region are we really interested in here? Well, that's this region here that we really want to know. So we can darken it in pretty good. Well, if the whole area to the right-hand side of the y-axis is 7, and that one's equal to 3, then we know that the integral from 2 to 5 is going to be the integral from 0 to 5 minus the integral from 0 to 2. Because all of the areas add up to the total, so it's going to be 7 minus 3 is equal to 4. So by drawing a good picture and by thinking about the integrals in terms of their component parts, we're able to determine the answer.